development of the hydrological regime of the Uzh River under backwater condition to minimize the urban environmental risk. Our work developed in the frame of the project the regulating via construction of the Uzh River in the city of Uzhgorod near Bozdosh Park. In short, the problem. Hydrological situation on the Uzh River is characterized by low levels during the dry season and flood which occur a lot of time during the year. The highest flood is occurred in spring and autumn. Bozdosh Park was laid inside the loop of the river. The floodplain lakes and old riverbed is situated in the park and replenished by water of the Uzh River using the spillway tubes. Unfortunately, now the sediment deposits blocked the tube and the flood lake are silted and covered with woody and shrubby vegetation, and the old riverbed is dry now. Several replenishment ways were considered, and it was taken the decision to create backwater on the main river Uzh to supply water into the lake and into the old riverbed. To create the backwater in the Uzh River was accepted the flap gate, which is situated along all the width of the riverbed to limit narrowing of the cross section, and the crest of the flap gate is located on the bottom level. The backwater is temporarily formed by the flap gate after the end of the spawning, after the 15th of May, and is maintained until the end of the October before autumn floods. The fish passage is necessary for fish move across the dam, and it is situated near the flap gate. The aim of the work to assess the main parameters that undergo changes during the backwater creation and to develop an environmentally friendly hydrological regime operation of the lower head dam to minimize the environmental risks. The environmental impact of the dam on the hydrological, biological and geomorphological parameters of the reservoir and water quality can be summarized using the diagram on the slide. The impact of low head dam with small reservoir on the hydrological regime, the mean annual flow, flood reduction is not very essential, but the small shallow reservoir accumulates the sediments, the pollutants, the biogenetic substances, and with increasing temperature can occur algae bloom and overgrowth of the reservoir and oxygen reduction as a result of blooming. The optimal functioning of the hydrobiotes ensure if water retention time is rate of 4 or 6 days. The water volume in the main reservoir on the river Uzh, the volume of the lake and old riverbed, the ecological flow downstream and water supply flow rate into the lake and into the old river bed, calculating using the water balance method. The peculiarity of this, the location of the hydraulic structures is that seepage losses from the main river move to lake and get into the same river down stream. So for all the system, the seepage is not lost, it's just location lost for upstream reservoir and for lake. Our calculation, we simulate two different scenarios for different hydrologic year. The dry year of 95% probability, the year of 75% probability, and for the mean year. The first scenario, we keep the water level in the main reservoir the constant. The water flow into the old river bed is 0.5 cubic meters per second, and the water flow rate into the lake is 0.3 cubic meters per meters, and the same constant. Realization of this scenario is easier for operation, but it create the ecological flow. It is red line, and this ecological flow downstream is less than 68% of inflow. The second scenario, we use the volume of the main reservoir. That's why the water level in the reservoir decrease lower than 2 meters, but we supply into the downstream the ecological flow, black line, the ecological flow not less than 75% of inflow, and it is the best variant for ecological flow. But the second scenario is more complex and demand complex automation of all hydraulic structures in water replenishment. Conclusion. The development of the hydrologically friendly regime is individual for each river and depends on hydrological, hydraulic, geomorphological regime and water quality of the river. But it is possible to single out general requirements for creating the hydrologically friendly river regime. To avoid blooming, it is necessary to keep retention time in the range of 4 or 6 days. To avoid overgrowing the reservoir, especially shallow reservoir, the depth of the reservoir should be more than 2 meters. Of course, hydrological regime of the river after the backwater creation should be correspond to the natural one, and ecological flow to the downstream should be at least 75% of the inflow of the river. As any reservoir creates the sediments barrier, it is necessary to provide a sediments transporting and washing out the riverbed during the floods by the full width of the riverbed. The flood level increasing, the water level fluctuation, and groundwater table increasing cause several problems with the urban territory. It's the bank stability, the influence on building foundation and soil mechanical properties, which require very attention and separate study. And of course, all low-head dams should be provided with automatic control system. And the crest of the wire must be at the same level and bottom level to prevent flood level increase in urban territory. Thank you for attention.